Millions of years ago, long before humans existed, and long before any creature walked on land, Earth was a completely different world. The oceans stretched endlessly, covering almost the entire surface of the planet. In the darkness of these ancient seas, life began its slow, patient climb toward complexity. And one day, after countless generations, that life would attempt something extraordinary, something that would change the future of the planet forever, stepping out of the water and onto land. This is the story of that journey. A tale of struggle, adaptation, and survival that eventually gave rise to every land animal alive today, including us. During the Devonian period, nearly 400 million years ago, Earth was far more like a water world than the planet we recognize now. On land, life was simple and sparse. Mosses, early plants, and a few primitive insect-like creatures clung to the soil, forming the very first ecosystems outside the oceans. But beneath the waves, life was flourishing. Coral reefs were expanding, fish diversity was exploding, and the oceans were filled with creatures unlike anything alive today. Yet, under this rich and thriving surface, an intense struggle was unfolding. Enormous predatory fish dominated the shallow coastal waters, some of them armored like tanks, others equipped with jaws that could crush bone. For the smaller fish that lived along the seafloor, survival was becoming harder with each passing generation. Competition for food was increasing, predators were becoming fiercer, and safe hiding places were shrinking. The ocean was no longer a guaranteed refuge. The pressures of this environment were setting the stage for a dramatic evolutionary experiment. Another problem was quietly intensifying: the oxygen crisis in shallow waters. As temperatures rose due to natural climate shifts, warm water began losing its ability to hold dissolved oxygen. Regions close to the coast became suffocating zones of low oxygen, where many fish struggled to breathe. Some died, others migrated to deeper waters, but a small group, one that would eventually change the course of life forever, took a different path. They adapted. These were the lobe-finned fish, a remarkable group with fins that contained bone-like structures. Their fins were not flimsy or flexible like the fins of most fish. Instead, they had strong internal supports, primitive versions of what would one day become limbs. These fish could lift themselves slightly above the seafloor, push through mud, and maneuver in shallow water with much more power and control than their competitors. What began as a small anatomical advantage would soon shape the destiny of life on Earth. As oxygen levels continued to decline, evolution delivered another surprising innovation. Some fish began rising to the surface and using parts of their mouth or throat to gulp air. Over millions of years, this behavior led to the development of early lung-like structures. These were not fully formed lungs like those in modern land animals, but they worked well enough to allow the fish to survive short periods in oxygen-poor environments. Suddenly, these creatures had a powerful double advantage. They could breathe underwater through gills, and they could breathe air when the water around them felt like it was suffocating. This combination would become essential for the leap to land. Around 375 million years ago, evolution produced one of its most iconic transitional creatures. Fossils discovered in the Canadian Arctic revealed the remarkable animal something between a fish and a land dweller. Tiktaalik had the scales and fins of a fish, but also the neck, ribs, and limb-like bones of a land animal. Unlike typical fish, Tiktaalik could turn its head, push its body upward, and support its weight in shallow water. It used its strong fins almost like arms, allowing it to drag itself across muddy flats and lift its chest above the surface. Tiktaalik's world was full of challenges. Shallow streams were unstable, drying up during hot seasons and flooding during storms. Larger predators often lurked nearby. But Tiktaalik's ability to move between water and land-like environments gave it an edge. It could escape danger, access new food sources like early insects along the shore, and survive in places where other fish could not. These small advantages were enough for evolution to continue shaping creatures that were increasingly comfortable in both realms. Why would fish want to leave the water entirely? Scientists believe there were several key reasons. First, the atmosphere offered far more oxygen than the oxygen-poor coastal waters. Second, the land provided abundant food. Early insects, worms, and other small invertebrates already existed there. Third, moving onto land allowed these early creatures to escape the massive predators that dominated the seas. And finally, land represented opportunity. A new world with almost no competition, no established predators, and plenty of space to explore. Evolution often rewards those who take risks, and these pioneering fish were unknowingly stepping into a world full of possibilities. Over time, the descendants of these adventurous fish continued to adapt. Their fins developed into stronger limbs. Their lungs became more efficient, Their bodies gradually shifted from swimming to crawling, and eventually, the first true amphibians appeared animals, like a cantistiga, and these creatures had recognizable limbs with multiple digits, functional lungs, and the ability to support themselves for short periods on land. They were still tied closely to the water, but they had taken the first true steps into a new environment that no creature had fully mastered before. From these early amphibians came the great lineage of land vertebrates. Reptiles, birds, mammals, and ultimately humans all trace their ancestry back to those early pioneers. Every step we take on land today, every breath we inhale through lungs instead of gills, and every movement of our arms and legs is a living reminder of the evolutionary innovations first seen in those ancient fish. The struggle of a small, determined creature lifting itself in a muddy Devonian stream may seem insignificant, yet it set the course for the entire future of life on land. It opened a door for forests, dinosaurs, birds, and mammals. It created ecosystems that would one day support civilizations. All of it began with a desperate need for air, a push against the shallow water's edge, and a brave attempt to explore a new world. This is the power of evolution. Small changes, small steps. But over millions of years, those steps reshape the world in ways nothing else can. And the story of how fish came onto land remains one of the most remarkable transformations in the history of life on Earth.